Hi guys, I had a question about number 9 in the derivatives of exponential functions homework day. I think it's probably this notation that is causing the problem. So it gives a function y equals 5 over 2 times e to the x over 5 plus e to the negative x over 5. And it asks us to prove that y, and then there's two kind of prime marks there. What this means is called y double prime. We haven't really covered it yet, but it will come up in the unit 5, so I thought I'd do a solution you guys can take a look at. This is not something that you will need on the unit 4 test for today though. So this is y double prime, and what that basically means is that we're going to take the derivative of this function, and then we're going to take the derivative of that derivative. So it's called a second derivative, and we'll cover this, like I said, in unit 5. But you would find the derivative and then take that new derivative function and find the derivative of that. And we want to prove that that's equal to the original function divided by 25. So let's take a look at how we could do this. First of all, I'm going to simplify or expand out my original function here. Y equals 5 over 2 times e to the x over 5 plus 5 over 2 times e to the negative x over 5. Now I'm going to take the regular derivative, or the first derivative here, and note that I'm changing notation from y equals to y prime equals. You could use dy dx too, but I'll keep with that because that's a notation in the question. So this is going to be 5 over 2 is my coefficient. Now to do the derivative of this piece, e to the x over 5, remember exponential functions stay the same, x over 5, and then we do the derivative of this little exponent piece. Now just to kind of show what I'm doing off to the side here, x over 5 is the same as 1/5 of x. Sorry, it's a bit off the screen. So here we've got x over 5, which is the same as 1 over 5 times x. And any derivative of a linear function with just a coefficient and an x is just the constant value of that coefficient. So I'm going to multiply this by the 1 over 5. Okay. Now I'm going to do the same thing for the second term. So this is going to be plus 5 over 2 e to the negative x over 5 times the derivative. I can put this in a bracket actually because I've got a negative. So the same kind of idea here, this would be negative 1/5 as the coefficient. Now when I simplify this up a little bit, I'm going to keep y prime here, just multiplying that 1/5 times 5 over 2, I get a coefficient of 1/2 e to the x over 5, and then a negative 1/5 times the 5 over 2, I get minus 1/2 e to the negative x over 5. I'm going to do the next derivative. So this was the first derivative. Now I'm going to do the second derivative, which really just means pretend this is the original function and do the derivative again. So I'm going to take the derivative of the first term. So the coefficient stays out front, e to the x over 5, and then the derivative of the exponent, which is 1/5. And then minus 1/2, same idea again, e to keep the exponent the same, negative x over 5, and multiply by the derivative of the exponent, which is still 1/5. It's kind of neat. You can get into some pretty neat repeating patterns with derivatives, multiple derivatives, second derivatives, third derivatives of exponential functions, because they do kind of follow this pattern that it's the function itself times a constant. And even pretty complicated multiple derivatives of exponential functions can sometimes simplify pretty nicely. So here we've got 1/2 times 1/5, so I have 1/10 e to the x over 5, and now I have negative 1/2 times negative 1/5, which is positive 1/10 e to the negative x over 5. So here we can simplify, factoring out that 1/10 e to the x over 5 plus, factored out the 1/10, it's not there anymore, e to the negative x over 5. So we wanted to prove that this is y double prime. We want to prove that that's equal to the function y over 25. So we could kind of put like a left side equals here. So if we said prove y double prime equals y over 25, we know the left side, which is y double prime, we've done this math and worked out the second derivative to be 1 over 10 times e to the x over 5 plus e to the negative x over 5. And on the right-hand side, we've got, try and move my phone a little bit, we've got y over 25. I'm going to rewrite that as just 1 over 25 times y, which is going to make this a little bit easier. And then I'm going to go back to the original question and sub in the whole function of y. So that's 1 over 25 times 5 over 2 e to the x over 5 plus e to the negative x over 5. Square up those brackets. And then if we multiply these coefficients, 1 over 25 times 5 over 2, that 5 is going to cancel, and we get exactly what we had on the left side. Like that. Okay, I'll post this video and I will post the PDF of the written solutions too.